We will use these materials: bakelite copper, TCRT 5000 sensors, cables, ferrite chloride, selenite bulb, 12-volt batteries, resistors, regulated electronic board or PVC. The first step to plate development is to clean the copper sides plate using a fiber to sand the plate. We must leave the copper braid. We need to remove the marks, the oxide after polishing the plate. We need a cotton ball with alcohol to remove the powder of polished copper. The second step is print of a sheet of glossy paper. The circuit design that you want to print on the PVC board has to be printed on a laser printer or photocopier with toner or an glossy paper. We can work in different ways with the figure, but it's necessary to measure the plate so that it's symmetrical with the plate and center in on it so that circuit is drawn to measure. A plate is put to head. The plate is cleaned again with the cotton and the figure that the one to rebel is necessary to tape the plate to be firm against the plate. It's necessary and very important that the print is done on photographic paper so that the imaging is clearer. At the same time, we must prepare a container with water. The container begins a sign so that the plate enters to receive once. For ironing, it's necessary to cover the plate with a piece of thick cloth to protect the plate from high temperature. It's very important that the heat to plate is not direct. We will put a time at 3 minutes to take our ideal ironing time. You will start ironing the plate with a movement from left to right while the moving so ironing is in this period of time. When the plating is finished, the hot plate grab the same with a safety glove and throw it into the water container left to hot plate. Rest for 10 minutes until the paper is soft. With the fingerprints, we get the plate begins to remove the paper little by little. With a carving of finger against the plate, open points that don't remove the paper between tracks.
To design this circuit in this project, I use a program Proteus 8 Professional, which is a program to design circuits, electronic circuits, logic circuits. In this part, I have my components, which is a regulator, diode, LED, a motor for simulate this, and Arduino Nano, blocks for together the wires, and some resistance. In this case, I need to connect with ground H in. Here is an integrated circuit which amplifies the current to active the relay. Here is a diode which take care the pass of current in 1 cent. This program is very useful because here you can design the PCB circuit which is shown here. However, this program doesn't have the library of Arduino, so I need to download it. Another very useful characteristic of this program is the 3D visualizer. we show my logic circuit, my logic in 3D. Front, you can turn up, down, left, right here, but before this logic was very ugly, so I need to design each part by another program which is SolidWorks. SolidWorks is a CAD software design. In this, with SolidWorks, you can design each part, and then you can add this in Proteus for 3D visualizer. In this case, I have to design this Arduino Nano because it's very important to have the measures of each part of our project. Here is the block. Once when we have our parts together, we can design a draw which show the measures to design the housing of our project.
Okay, I am going to explain you the programmation. In our project, the programmation is going to be an essential part because we're going to make an automatically dispenser of water. So we need to check the indication about every component. We are going to use 4 sensors. It depends the size of the bottle. We are going to use an Arduino Nano, cables, the electrovalve, and a controller, and a pilot controller. Okay, so I am going to show you the circuit. This is the circuit. Here we have the Arduino. This is a bridge H to receive and to give the information that give the Arduino, the sensors, and the pilots. So in this case, we are going to put an example. For example, if we put a water about a quarter of a liter, I'm saying that it's going to be the smaller size of the bottle. So in this case, only the first sensor is going to detect it. So the sensor is going to give the signal to the Arduino that only the first sensor is detecting the bottle. So in this case, the bottle is about a quarter of a liter. Then the Arduino gives the information to the bridge H, and the bridge H gives the information to the pilot to open the electrovalve, and it depends about what or how much of water the electrovalve releases per second. In this case, we are going to say that the bottle of a quarter of liter is going to be full in, I don't know, 15 seconds, for example. Then, for example, if another person put a bottle about and a half of a liter, it's going to detect the 2 first sensors. So in this case, the second sensor, it doesn't going to say that it's going to be open, I don't know, 30 seconds, because we have the first 15 seconds and it could be a waste of water. So in this case, the first sensor is going to give the first 15 seconds,
and then the second sensor is going to give another 15 seconds only to complement the first sensor. Okay, so that's the function about the programmation in this case. So we need to connect the sensors and the electrovalve at the same time. They need to be synchronized and they need to respect the order and the times. And then we can have a great result, and it couldn't going to waste water. For the part of the design was made with a program of SolidWorks where part was designed to will work together. In this system there are a lot of things. For example, the principal things are laser sensors, water filters, and a water container. The laser sensors will work turning on the device and detecting what kind of bottle is in the base. The water filters will clean the water that will giving the to the people. The water container is the part that the water is keeping and will give to the people. All of these parts can be made with a printer 3D that can be building in an amazing time. It only is a prototype since in the future it will be assembled in the purifier. This prototype contains the real measures that that will be built.
The water purification. After the water has been transported to a central location, the process of purification begins. We have the steps for the purification. First, the coagulation, where the chemicals are added that cause small particles suspended in the water to clump together. After this is the flocculation follows, which mixes the water with a large puddles so that coagulated particles can be brought together into larger clumps. We have the sedimentation, basins smooth treated waters along through the purification process. After we have the filtration, which removes the remaining suspended particles and unsettled fog. We have the disinfection, that is the final step in the water purification. The advantage of the order and cleaning in the work areas. We have the implementation of the 5S is based on teamwork. Um, these rules give us less detected products, less breakdowns, less accidents, lower level of stocks and inventories, less useless movements and transfer, and less time to change tools. Through organization, order are cleanliness, it achieves a workplace for everyone since it achieves more space, satisfaction for the place where you work, better images to customers, major cooperation and teamwork, greater commitment and responsibility in the tasks, and major knowledge in the workplace.